Hello, welcome back to week 7 of ECE 9013 course. In this week's lectures, we will be discussing the basics of object-oriented programming and how we can implement this concept using Python. So we will be discussing what are objects, what are classes, what are attributes, what are getters and setters method, information hiding, class variables, and inheritance. So starting off with objects, Python basically supports many different types of data as we have previously seen. We have integers, we have floats, we have strings, we have lists, we have dictionaries. So each of these is an object, and every object has a type, an internal data representation, whether it's primitive or composite, and a set of procedures to interact with this object. So an object is basically an instance of a type. As an example, the number 1, 2, 3, 4 is an instance of the type int. The string hello is an instance of a type string. In object-oriented programming, we basically consider everything as an object. So everything in Python is an object, and it has a type. We can either use predefined types, such as integers, floats, lists, and so on, or we can create new objects based on new types. So basically, we can create new objects, manipulate objects, and destroy objects either explicitly using the del command, or we just quote-unquote forget about them. So Python will reclaim destroyed or inaccessible objects using what we call the garbage collection process. So what are objects? Objects are basically a data abstraction that captures two things: the internal representation, and this is done through data attributes or characteristics, and the second is the interface to interact with the object through methods, or what we also call procedures and functions. And this allows us to define particular behaviors, but still hiding the implementation side of it. So, as an example, this variable has a type list. So how are lists represented internally? In memory, they are basically a set of linked cells. So we have the first value with the first pointer, and then the second part of that cell points to the location of the second element within that list. And then again, the second element points to the location of the third element, and so on. So we basically follow the pointer to the next index. How do we manipulate lists? As we've shown in previous lectures, there are multiple operations such as accessing one element, multiple elements, concatenating lists, determining the length of a list, the minimum value, the maximum value, deleting a particular element, and other operators. This internal representation should be private. And this is because correct behavior may be compromised if we manipulate the internal representation directly. So it's important to keep the internal representation private. So the advantages of object-oriented programming is that it bundles data into packages together with procedures that work on them through well-defined interfaces. It allows us to follow the divide and conquer development process in which we can actually implement and test the behavior of each class separately. This in turn helps increase the modularity and reduce the complexity. Classes also make it easy to reuse code, and this is through the different Python modules in which we can define these new classes, with each class having a separate environment. Additionally, inheritance allows subclasses to redefine or extend a selected subset of a superclass behavior, which we will be discussing in further details at the end of this lecture. So for example, to create and use our own types with classes, we need to make a distinction between creating a class and using an instance of the class. So creating the class involves defining the class name, defining the class attributes or characteristics. For example, someone can write a code to implement a list class. On the other hand, using the class involves creating new instance of the objects and doing operations on the instances. For example, here we create a new instance of a list type, and then we can perform some operations on it, such as determining its length. So to define your class, we use the keyword class. Then we put the name of the class or the type that we want to create, and then we put the object, the keyword object, to create that this is an object that will be defined. So similar to the DEF word in which we define functions, indenting code indicates which statements are part of the class definition. The word object means that keyword is a Python class and it inherits all of the attributes defined within it. So coordinate is a subclass of object, and object is a superclass of coordinate. So what are attributes? Attributes are basically information or data and procedures that belong to the class. So data attributes are basically the characteristics of the object. For example, a coordinate is made up of two numbers, the x value and the y value. The second type of attributes is the methods or procedural attributes. Methods are basically the functions that only work with the class or with objects within this class. It defines how we can interact with the object. For example, you can define a distance between two coordinate objects, but there is no meaning to a distance between two list objects. So, to define how to create an instance of a class, we first have to define how to create that instance. To do that, we use a specialized method called _init_ to initialize the data attributes. So for example, we define that we have a class coordinate that is of type object, and then we define the initialize method. Here we have the keyword self, which is a parameter to refer to an instance of the class, and we define what are the variables that we will initialize the object with. So this init is a special method to create an instance, and we have this double underscore before and after. And then here we define the data attributes. So self of x is equal to x, and self of y is equal to y. So these are two data attributes for every coordinate object. To create an instance in the actual code, we can define C as a variable of type coordinate with an x value of 3 and a y value of 4. And then define another variable, origin, with the coordinate to be 0 and 0. Then here, for example, we are printing out what is the x value for each of these two different variables. So data attributes of an instance are called instance variables. When we are using the class, we don't need to provide the argument for self. Python does that automatically. Thank you.